Everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be going into the next phase of systems of equations. This is something that we did last year, and so this should just be a little bit of review for you. Last lesson we did some graphing and we did some substitution, and that's how we solve the systems of equations. In this lesson, we are going to be doing what's called elimination. I'm not going to spend a lot of time on this because I think most of you probably remember this. So as soon as I do one or two, you should be good to go. Well, let's just jump right into it. So here's our system right here. We have two equations. And what we want to do is we want to cancel something. We want to eliminate something. So the steps of this are kind of the idea is to add or combine these, and you would add the x's, the y's, and then the constant term. All right, so let's try it, see what happens. 2x plus 4x is 6x. Now look what happens right here. That's where the magic happens. Those two cancel. That's what we need to happen. If we don't get that, then we have to do something else. But in this one, hey, the magic happened. It canceled. That's great. And then you come over here, negative 12 and 24. That gives you positive 12. And then you would just solve the equation, divide both by 6, and you end up with x equals 2. So our x answer is 2. Now what do you do? Well, you'd take that x answer and you would pull it back and you would plug it into one of these. Let's plug it into the first one. So 2 times 2 minus y equals negative 12. 2 times 2 gives us 4. 4 minus y equals negative 12. Subtract 4 from both sides. That's going to give us negative y equals negative 16. And then we got to get rid of that negative, so we'll do that. Let's divide by negative 1, and that will give us, that's cancels the negative signs. We get y equals 16. So there's our answers. Our first answer is going to be x equals 2. Our second answer is going to be y equals 16. Then we just have to figure out how are we going to write this? What kind of format should this take on when we write our answer? Well, it should look like an ordered pair. So you should have 2, comma, 16, and let's put some parentheses on that thing before we circle it. There we go. And that looks like an ordered pair. That looks like something that you could graph. What is that? Well, that's the solution. What does that mean? That's where the lines cross each other. That's the X marks the spot right there. Now remember that there's some other variations. What happens if you get parallel lines? Well, when you do elimination, here's what that looks like. You end up with like when you go to cancel your things, your variables, you get something like 6 equals 7. You're like, what? 6 does not equal 7. Well, that means no solution, or that means that they were parallel lines. Let me show you another type of situation that you could come up with. You could have a line on top of the other line. That's called coincident lines. That means that they touch in every single spot because they're on top of each other. So what do coincident line solutions look like when we eliminate? Well, it looks like this. 7 equals 7. In other words, no matter what you put in for x, you get the same answer and no matter what you put in for y, you get the same answer. In other words, they will always match each other. No matter what input you put in, you are going to get the same. Why? Because it's the same equation. It's the same line. And so you're going to continue to get the same answer. So that looks kind of like that. 7 equals 7, 0 equals 0, whatever. Any number, 3 equals 3, doesn't matter. So if you get a number like 3 equals 7, no solution. If you get 7 equals 7, then it would be infinite solutions. Or those are coincident lines that are right on top of each other. Okay, so that's just two other things that you might see. Let's do one more. It's a little bit more challenging, and then we'll be done. So like I said, short video. So now here's the problem in this one. This is our problem. When we go to add this thing up, look what happens. I get 5x plus 5y equals 5. Well, we got a problem. Our problem is that nothing canceled, okay? And so the whole idea of elimination, nothing eliminated, nothing canceled out. So we have to do another step sometimes first. So let's go back here and talk about what step would we use. Now, when I tell students that this is a place where you're going to use the least common multiple, you're like, I don't even remember what that is. Well, let me kind of explain to you what that is and kind of explain what you're looking for. You are trying to get these two terms to the smallest number that you can that will cancel. What do I mean? I mean, if I multiply this by 3 and this by -2, watch what happens. This goes to 6 and this goes to -6. And look what happens here. Cancel. Okay? So that's what we're looking for. We're trying to find a multiplier. We're trying to find something that will make those two cancel out. That's what we want to do. You could also look for something that would make the y's cancel out. That's a fine way to go. You can cancel the y's, cancel the x's. It doesn't matter. You're still going to get the same answer, no matter which variable you cancel. Well, in this case, let's go ahead and make two new equations, one distributing the 3 and one distributing the 2. So let's do the 3 first. So we're going to get 6x plus 9y equals 15. Okay, so we're done with that one. Now let's go ahead and distribute that -2, and that's going to give us minus 6x minus 4y equals 0. I like 0. 0 just stays 0. Like, it's an easy number to work with. Ones are easy to work with, and zeros are easy to work with, right? And so that's whenever I see ones or zeros in my equation, I like those because those are easy to work with. All right, so now we're just going to come down here. Now we're back to where we started from. We are canceling. Boom, those things are gone. And we go ahead and add those. 9 plus -4 is going to give us a positive 5y equals 15. Man, this is easy. Look at this one. Divide by 5, divide by 5, y equals 3. There is one of our solutions. But that's only one of our solutions. We have to take this 3 and plug it back in. Now, I personally like to plug it back into one of these original equations. Okay? I don't like, now, it would work. Technically, it would work if you plugged it into one of these equations. It's fine. But I don't like ever plugging it back into an equation that I've already manipulated, because what if I did something wrong? What if I made a mistake? Plug it back into an original, and then you don't have to worry about that. So, all right, so again, you pick whichever one you like. I'm going to pick this one because it has a 0 in it. That makes me happy. So I'll go ahead and do that one. So remember, what was our number down here? It's a y equals 3. So where the y is, we put a 3 in there. So 3x plus 2 times 3 equals 0. All right, so multiply that out. 3x plus 6 equals 0. Minus 6 minus 6. We got 3x equals -6. All right, so divide by 3, and that's going to give us x equals -2. X equals -2. So there's our answers. We have x equals -2 and y equals 3. Let's write it in an ordered pair, -2, 3. And there is our solution. Okay? Now, how do you check that? How do you verify that that's right? Well, there's several different ways that you could do that. That's one of the things I like about algebra. You can do it different ways. You could graph these if you want. So take your graph paper and graph those equations. Put them in y-intercept form if you want. Put them in, find the intercepts. Okay, so switch out the x for 0 and the y for 0. Graph them that way. However you want to graph them is fine. But graph those two lines, and they should cross each other at -2, 3. So that'd be a good way to do it. What's another way? Well, take this number, -2, 3, and plug it back into one of those. And watch what happens. Let's plug it back into the top one. 2x plus 3y. 2x plus 3y equals, that was 5, wasn't it? Yes, equals 5. All right, and now we're just going to plug both in, so negative 2 and 3. So 2 times negative 2 plus 3 times 3 equals 5. And let's see if this indeed does equal 5. 2 times negative 2 is negative 4, plus 3 times 3 is 9, equals 5. Negative 4 plus 9 is 5 equals 5. So boom, there we go. And that's a way to check it. You can just plug both of your answers into an original equation and see if it works out. Graphing is also a valid way to check this. All right, there you go. If you missed anything, make sure to go ahead and rewind that back and make sure you watch it again. But I think most of you probably do remember this concept from Algebra 1. So maybe a little bit of a light day here in Algebra 2 class. All right, we'll see you later. Bye-bye.